Hello again, this is Mrs. Gillihan with another problem on how to find the distance between 2 points on a coordinate plane using the Pythagorean theorem. And the goal, of course, here is to connect what we are doing with the slope formula, which we'll talk about here. In this case, we have 2 points plotted. We have -3, 3 plotted right here, and we have another point, 2, 8, plotted right here, and we are being asked to use that Pythagorean theorem in order to find the distance between these 2 points. First of all, let's actually connect the points so that we can find the slope of a line that connects these 2 points. And once we do that, we will then be able to hopefully see the connection to the Pythagorean theorem. So if I have -3, 3 and 2, 8, and I connect those, visually I look at this line and I can see that the slope is an up 1 over 1 pattern. So I do have a slope of +1 with this particular line. But let's go ahead and take a look at how that translates into the slope formula. If I use y2 minus y1 over x2 minus x1, which is the formula for finding slope of a line, I can see that I have m equals, y2 is 8, and y1 is 3. 8 minus 3 gives us 5. And I can see that I have x2, which is 2, and x1, which is -3. So I end up with 2 minus -3. 8 and that also equals 5. So I end up with a slope of 5 over 5. And that reduces to a slope of 1. We can see that happen numerically with the formula. Now let's take a look at what that looks like in terms of a rise and a run. We're actually going to complete the triangle making a perfect triangle all the way up and another line all the way over. I'm going to avoid just doing the up 1 over 1 stair step business right now so that I can actually see what's going on with this right triangle. And again, we're sure that it makes a right triangle because the coordinate lines, the natural lines on the coordinate plane, we assume that they form 90-degree angles. So when I form a triangle using those, I am certain that I have a right triangle. So let's change the color of these in order to be sure. I'm going to make the rise blue, and I'm going to make the run, I'm going to make green. Let's see, let's go with this green right here. And so I can see my rise is 1, 2, 3, 4, 5, which we found. The rise is the rise, as we see here, and the run is the green here, 1, 2, 3, 4, 5. And we have a run down here of 5. 5 over 5 is the run for this particular triangle. And we also note that we have a right triangle with leg 1 is here. Here's one of our legs right here. A second leg of our triangle is right here. And our hypotenuse is the black line, which is always just exactly diagonal of that 90-degree angle. Very important to be able to identify the hypotenuse. Okay? So we have identified the sides of our right triangle. And let's label those sides in units. So my blue leg is 5 units long. And my green leg is also 5 units long. And there we go. So we have a right triangle. Both of our legs are 5 units long. Now and we see that here. We see a rise of 5 and a run of 5. Very important to make that connection, of course. So now we're going to go to part 2 of this, which it's asking us to use the Pythagorean theorem in order to find the distance between the 2 points. So in other words, we're trying to find out how long this black line is. And we're going to use the legs of our triangle in order to do that. Okay, so let's take a look at the Pythagorean theorem. We have a squared plus b squared equals c squared. And it's very important to recognize that the c is always the hypotenuse. So the black line here is our hypotenuse, and that is the missing piece that we are looking for. So let's go ahead and input what we know into this Pythagorean theorem. And I'm going to take my blue leg right here, and I'm substituting it for A. It doesn't matter which you use for A and B, so long as you make sure that you use the C appropriately. And then we are going to take our green leg, which is 5 units long. We're going to plug that in for B. And once we get those numbers plugged in, we can start the simplifying process. And 5 times 5 gives us 25. for the blue leg, and 5 times 5 for the green leg gives us 25 for our simplification process. Once we continue that simplifying, 25 plus 25, we get 50, and that c squared is still c squared. Now my expectation on your quiz is that you are showing these steps, that you are showing the work, and that you are being very clear about where this information is coming from. I do not want to simply see a number appear on your paper. You will not get credit for it, I promise. Okay? So we need to make sure that this c squared is simplified. C squared is not a fully simplified equation. So in order to do that, we are actually going to take the square root of both of these sides. In order to magically undo a square, we take the square root. But what we do to one side, we have to do to the other. So we're taking the square root of c squared over here, and in order to keep the equation balanced, we're taking the square root of 50 on the left side of the equation. And when we do that, square root of c squared is c, and square root of 50, because it is not a perfect square, we leave it as an exact number, square root of 50, and that is as far as we need to go with this. We do recognize that it's just a teeny tiny bit over 7, because 7 times 7 is 49, so it's very, very close to 7, but just a tiny bit over. So that's how many units. It's just a little bit longer than 7 units long our hypotenuse is. Okay? Now the connection that I'd like to make here very quickly is that this 5 and this 5, as part of our rise and our run, are actually numbers that appear in the Pythagorean theorem process for this problem. So our rise ended up here, and our run ended up here. And notice that when we did simplify this slope, we ended up with a slope of 1. We do need to make sure that if you're using the slope to help you find numbers that plug into the Pythagorean theorem, you do need to make sure that you use the original numbers that before simplifying. Make sure you're using the 2 5s, and that we don't want to use 1s in our Pythagorean theorem. That obviously would not get us the correct distance of this, or the correct length of this hypotenuse. Alrighty, so for your test on Thursday, this is what you're looking at, and I hope you study well and you are able to explain the connection between the slope that we see here and the numbers that appear in our process for finding the distance between 2 points on a coordinate plane.